Yeah, this question is asking obtain the direct form 1, direct form 2, cascade and parallel structures for the following system. And here's the equation given. Y of n is equal to 3 by 4 y of n minus 1 minus 1 over 8 y of n minus 2 plus x of n plus 1 over 3 x of n minus 1. Now in order to obtain equation, we have to find out what is the age of z. To find that one out, what we have to do is we have to separate the y terms and the x terms. So here you see we have y of n right here, and I can bring all the other y terms to this side. In that way this will become minus 3 by 4 y of n minus 1 here, and minus 1 over, actually plus when I bring it to the other side of the equation, so 1 over 8 y of n minus 2, and we keep the x terms in the other side, so of n plus 1 over 3 x of n minus 1. If we arrange in this way, we don't make mistakes in the signs, because when we put it in the h of z form, what we do is we put the x coefficients on the top and y coefficient on the bottom, and whatever the shift we have, that will be represented with z transform. So here if I express the x terms in the numerator, if it's x of n, then there's no shift here, shift is 0, which means this is going to be just 1 times z power 0, which is 1, so this is just going to be 1 here, and then plus 1 over 3, and if we have a shift of minus 1, like shift 1 unit to the right side, which means z power minus 1. Okay, and if you look at the y terms, we have y of n, again there's no shift, which means this is the shift is 0, which means z power 0, so this is going to be just 1 here, and then minus 3 by 4, and we have a shift of 1, so we are going to get z power minus 1 for this, and then here we have 1 over 8 and then shift of 2, so we're going to have z power minus 2, and this is the edge of z equation. Using this one, we can draw the diagram for the direct form 1 and direct form 2. Okay, for the cascade and parallel, we have to find out h1 of z and h2 of z. In both cases, h1 of z and h2 of z are going to be different. We'll see that cases later. So to draw the direct form 1, direct form 2, I'm going to grab this equation, bring it to a new page. Okay. Now what we do is we look at we put a plus sign this side and another side, and then we see what are the zeros and poles. If we have zeros, the arrow is going to be this side, and if you have poles, the arrow is going to be this side, and we will put the coefficient for this. And for the poles we put the coefficient, but the coefficient will be, since the direction is opposite, we put a negative coefficient. We know that the numerators are zeros and the denominators are poles, so based on that we have to draw the diagram. Okay, now we know that this is x of n, and first you see this one here without any z transform, which means this is this one right here. This is just a 1, you don't have to put it if it's just 1. If it's some other term, you have to put it, like if it's 1.2, then you put it right here, but otherwise you don't have to care about. So we are going to have that one here, and then when I go to the next one, after the z power minus 1, we have to take care of the other coefficient. In this case, we only have 1 0, which is the coefficient is 1 over 3, so we are going to have that one over here, that is connected to over here. Okay, so that is the only thing we are going to have here. Then now we move to the poles. Okay, for the poles, we have one here, that is this one, and then the next thing is we have 3 by 4 in the z minus 1. So let's put that one here. Z power minus 1. We have negative 3 by 4, but the sign will be opposite because we put a minus in front. This is going to be 3 by 4 here. And then since we are going to have another pole here, we put a plus sign here because this is going to extend. Okay. And another Z over minus 1. And the coefficient for this one is 1 over 8, and we put the opposite sign, which is negative 1 over 8. Okay. And that is the diagram, and this side is y of n. Okay, now this is the direct form one. For the direct form 2, what we do is we combine these two diagrams together. We bring this side of this one in front and this side is behind. In that way, we will reduce one of the z power minus 1 required. If we draw that one here, let me separate with a line. Now I'm gonna, for the direct form 2, okay. X of n, y of n remains the same. And then y of n. Now what we do is we bring these terms to the front. So we are going to have a plus right here and another plus over here, and we have z power minus 1 twice. Connected like this, and this term we combine with this one, so this z power minus 1 is this one, and that is connected with a plus over here. Okay, and we can keep the arrows direction as it is, and the coefficient remains the same. So if it's 3 by 4, 3 by 4 here as well, minus 1 over 8, and this coefficient is 1 over 3. Okay, so as you can see, we just combine these two together and that becomes the direct form 2. Okay. Now, um, now for the next part, we have to draw the cascade and parallel. For the cascade and parallel, we follow the direct 2 form pattern. In the direct 2 form pattern, you see that poles are on the right side of the equation, actually left side of the diagram, and the zeros are in the right side of the diagram. So for the cascade and parallel, you have to follow the same thing. So in order to draw the cascade and parallel, we need this equation, but we have to separate them. Like, let's do for the cascade and parallel. It's going to be different way of separating for the cascade and parallel. Let's see one by one. So first, if I do it for the cascade is easy. You have to think in terms of multiplication and adding. For the cascade, what we do is we separate two terms, and we separate like h1 of z and h2 of z. For cascade, we just multiply. For the parallel, we add them. Okay, that's the difference. So here for the cascade, we just multiply. The best way of separating for the cascade is, what we do is we first we had to factor the denominator. We have to factor this one. Here you see we have minus 3 by 4. If I add, if I add two terms, I have to get minus 3 by 4, and when I multiply, I have to get 1 over 8. To get that one, what numbers we can combine. So I want to get minus 1 when I multiply. Actually, when I multiply, I have to get 1. So I have to think some terms that will do that for me. And in the denominator, I have to get 8. So I see a pattern, like I see some numbers that is, you can get 2 over 16 if you have like 2 over 4 and minus 2 over 4 and minus 1 over 4. You multiply that one, that is 2 over 16, that is equal to 1 over 8, and minus minus turn into positive, so I can factor in that way. So this will become 1 plus 1 over 3 z power minus 1, and then the denominator, if I factor minus 2 over 4 minus 1 over 4, minus 2 over 4, I can write it as minus 1 over 2 as well, z power minus 1, and then 1 minus 1 over 4 z power minus 1. So we can factor like this. So the next thing is, we have to get h1 of z and h2 of z term. To get h1 of z, what we can do is we can keep the numerator as it is, 1 plus 1 over 3 z power minus 1 over, we take the first this factor, that is 1 minus 1 over 2 z power and then we have to do the multiplication. So for the next term, we have to just think it as multiplying this one by 1. So we take 1 here, and we take this factor 1 minus 1 over 4 z power minus 1. Now what we do is we draw both of these individually and connect them. When we draw this one, we had to draw it in a direct form 2 pattern. So if I draw this one, here we have 1 0 and a 1 pole. So we are going to have plus plus, because since we have a 0 and a pole. And direct form 2, we put the z power minus 1 in the middle. Okay, now this side we are going to have the pole, and we have to see what's the pole. We have 1 over 2, and we know that pole is going to be opposite sign, so if it's negative 1 over 2, we're going to have 1 over 2 here, and the 0 is 1 over 3, the sign remains the same, so 1 over 3 here, and that is for the h1 of z. Here this is x of now the next thing is I have to draw the h2 of z. For the h2 of z, I have only a pole here, so I just need a 1 plus, because I'm only going to have one side of the diagram, and again z power minus 1. Since it's a pole, it's going to take the opposite sign. It's minus 1 over 4, we are going to have 1 over 4 here. Okay, and then we connect it with a plus, and this is y of n, and this is the second diagram for the second one, and after that we connect them together. and this is the cascade. Okay, now next we can look for the parallel. For the parallel, the separation is going to be different. We bring the same equation. Now we don't do like before. We are going to derive h1 of z and h2 of z, but the way we do this one is using partial fraction decomposition. First, what we do is we have to do the factor like before. So we already know the factor before, that is this one, 1 minus 1 over 2 z power minus 1. But we put a constant on top as well to do the partial fraction. So this is a over 1 plus 1 minus 1 over 2 z power minus 1, z power minus 1, and 1 minus 1 over 4 z power minus 1. This is b. Now you have to solve for a and b using the partial fraction decomposition. That's going to be a long process if I start doing that, so I'm just going to skip that part. If you want to get an idea, like, you can watch my videos on the partial fraction decomposition. That's easy, but it's going to take long if I do that here. So I'm just going to put the values and complete it. Here, if you do the partial fraction and solve for it, you will get 10 over 3 here, 1 minus 1 over 2 z power minus 1, and then here you will get minus 7 over 3, 1 minus 1 over 4 z power minus 1. Okay, to get the idea, like, if you don't have any idea how to do the partial fraction, I will give a slight idea how to do that. Let's look at an example for the partial fraction. Okay, just for the sake of understanding partial fraction, in case if you don't know. Let me grab a pen here. Okay, let's say we have something like 7x, or just doing a partial fraction, just for an example, 7x minus 23 over x minus 2, x minus 5. And in the other side, what we do is, we, as we did before, we take each of these factor and put a coefficient on, like, we put a constant on top. So x over x minus 2 plus b over, I mean, a over x minus 2 and b over x minus 5. And after that, we bring this denominator and multiply in the other side. In that way, we will have 7x minus 23. And when we multiply, this x minus 2 cancels, and a will be multiplied by x minus 5. And in this one, we will have b times x minus 2. Then what we do is, we substitute a value for the x that will make one of them 0. So here I can substitute 5 or 2. Like, they start 5, then this term becomes 0. Then I can this is 5 minus 2, 3. So 3 times b, and this is going to be 7 times 5, which is 35 minus 23. So this is going to be 12, b 3, and we solve for b, which is 4, like that. Now for the next one, we put 2 for the x value in order to cancel, make this one 0, and solve for a. Okay, like that. You can solve for b and a like that. That's how we got these values. Okay, now once you have got that one, now we can go ahead and draw the parallel. Now we have already here for the parallel. Similarly, like, we use the direct form too. We have to see the zeros and poles. If you look at this one, we only have the poles, we don't have any zeros, which means we're gonna have one plus here. Plus here, and then z power minus 1. And we have to see what is the pole we have, and the sign is going to be opposite. So here negative 1 over 2, which means 1 over 2. And then here what we do is we put the value on top. This is 10 over 3, so which means this is going to be 10 over 3. And for the parallel, the next diagram is going to be right below this. So for this one also, we only have one pole here. We don't have any zeros. So we would just put 1 plus, and then z power minus 1. Z power minus 1, and then again, what's the coefficient? Negative 1 over 4, so opposite sign 1 over 4 here. And we see what is on top. That is negative 7 over 3. That's going to be here. And then we connect both of them with a plus, and that's going to be our y of n. You can also show the arrow here as well. And for this one, since we already have a plus, we don't need to put any other plus, but this is our x of n. Okay, that is the parallel. This arrow is even not even necessary. This is parallel. So you see the difference between parallel and cascade. For the cascade, we just separate the we factor this one and separate one term as it is. Like we put the first term as a numerator for the first factor, and for the second one we just put 1 on top of it, and then separate and do connect it serially. This one we connect it parallel, and we find the equation for h1 of c and h2 of z using partial fraction decomposition. And that's how we do this kind of problem. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.